Hello students, let's look at while loops, which are condition controlled loops. There are two types of loops in Python: for loops and while loops. In other programming languages there might be variations of while loops or for loops, like for each loops, do while loops. In Python it's just two, right? So a while loop can be as simple as just typing while, and there's got to be a Boolean condition next to it. So the while loop will continue as long as the statement is true next to it. So I could say, and this is dangerous, don't actually run this, hello true, print hello. Now this will continue forever because that true is never going to become false, and it will just keep on printing hello and eventually crash, cause problems. So lots of bugs happen this way. So how can I improve this? Well, I don't want it to run forever necessarily, so what I might need to do is have a count. So I can say count equals 0 to begin with, and then every time this goes round, maybe I update the count by 1. So another way of saying that could be, which is probably easier, is count plus 1. It's the same thing, they do exactly the same thing. And let's say if my count does equal like 10, so I don't want to say hello more than 10 times, then there are a couple of things I could do here. One is I can break the loop. I can actually stop it running. I can force it to stop running. So if I just clear the console and run it, there you go. So I'll say hello, and it's not doing it forever because I'm breaking it once count equals 10, because I'm updating that variable that we initialized with the integer 0 earlier. That's one way. Another way is we could have a variable called keep running equals true, and instead of writing true in here, we could say keep running. While keep running is the same as saying while true at the moment, because keep running equals true. So I could say if we get to count equals 10, then I want to change the value of keep running to be false. And if I do that, it does the same thing. It will stop the loop from running. So there are two ways we can control how long that while loop goes around for, which are quite helpful. So let's work on a countdown timer. So I could say starting num, let's just call it 43. Let's get rid of that space, that will be a problem. No spaces in variables. Starting num equals 43. And then I can say while starting num is greater or equal to 0, because I don't want to have a minus number, I'm going to print it out and update the value of starting number, because I want to, let's say I want to count down using 3s, so I've got 43, 40, 37, etc. So then I can update my starting number by using minus equals 3, which will take away 3 each time this while loop goes round. So if I run that, it will say 43, 40, and it will stop at 1, and it won't go any lower than that because the condition there was greater than or equal to 0. So this is another way that we can start controlling how these loops, how many times something loops. But it works quite well. I mean, you could obviously use a for loop for doing this, using the range function and the third parameter step. So you can write for loops and while loops interchangeably, but obviously it's sometimes just more appropriate to have an iterator that stops rather than sort of having a count variable as well. So it can be more efficient to use a for loop. But I'll give you an idea. So let's just say j equals 10, and for I in range, we're going to use a for loop here and then write it as a while loop. 0 to 10, start value 0, stop is 10. And this will be a sort of little countdown as well, but with a little message. So j's going to be, starts off as 10, but we're going to do something to it every time the loop goes round. So I'm going to say here, more times. And then every time the loop goes around, we're going to say we're going to -1 from j. And then finally, we'll print done. Let's use capital D in there. Okay, so let's just run that. 10 more times, 9 more times, 1 more times, done. Right. Fine, no problem. Another way of doing this, obviously, would be to use a step counter like that. It is if you'd have, you can have a step counter, but the start value would be 10, and then you'd go -1. But we're just getting ahead of ourselves. Let's just stick with what we had. So how would we write this as a while loop, doing the same thing? Well, we can say j equals 10. While j is greater than 0, colon, j, let's print out the number first, otherwise we'll get a problem. More times. Then we'll change the value of j. Done. Okay. Same thing. Right, doing the same thing. So sometimes you'll find while loops are a little bit more appropriate for the task. Like we don't know exactly how many times we need to loop until we find something. And then a while loop's more appropriate. If you know how many times you're iterating, then a for loop is probably more appropriate there. Like if you've got a deck of cards and you know you need to hand out a certain amount and you've got a certain amount of cards, then you can use your for loops. Otherwise, while loop might be better. So let's just do another example. And let's have a number. Let's just say, I don't know, 7. And we're going to double this number continuously until the length of the number gets to 7. And we want to then stop our loop from running. So we've got while, we can have while. What's our condition? So we can have the length of our number. Now what we want to do is convert our number into a string to do this, because we've got length as a built-in string method. Sorry, string function, subroutine, subprogram, not method, apologies. It's like a little built-in function that returns the length of the string, or an array if you pass through that as well. And so we convert our number to a string, and if as long as that is not equal to 7, we'll carry on with our loop. And then we'll say a num times equals 2. So this is a way of timesing it by 2 every single time. And then outside the loop we'll say, okay, what was our final number? We kept on timesing it by 2 and we stopped at a certain point. Now we don't know how long it's going to take, but it will stop eventually. Okay, there we go. So we've got 1,835,000 because this loop did satisfy this condition. We had a number that was less than 7 digits when the loop started, but because the loop started its job, it did double it and ended up with a number that was more digits. So that you've got to be mindful of that. So but you can match conditions here as well. There's nothing to stop you saying you can have and all sorts of other things. So you can have quite complicated logical statements there to keep the while loop from running amok. Okay, let's see if we can give you another example. I'm going to give you a slightly tricky problem here, and that's Fibonacci number sequence. I don't know if you're aware of this Fibonacci number sequence. Start with 0 and 1, and you add the 2 preceding terms together, and what you end up with is this beautiful sequence which is related to golden ratio. So how on earth would we've got sort of two problems here. How can we use a while loop to generate this? And also, how would we actually generate it? How would you ask a computer how to count like this? Well, we could use for loops or while loops to do this, but it's certainly appropriate to use an iterator. And logically, it makes sense to have two values to begin with, A and B. So we can say A equals 0, B equals 1. And then you've got your 0 plus 1 is 1, which is this term, which we could say is our next value of A, if you like, and our next value of B is 2. So 1 plus 1 would equal 2. And then this way, logically, we can keep saying A and B, A. Oh, Chinese characters in there. B. This is probably the most logical way of approaching this. So you've got a pair of numbers that you're continuously updating every time a loop goes round. So we could, and let's make a I'm going to say Fibonacci list. I'm going to initialize an empty list here. Now we'll do a little bit more work on lists in another video, but lists are a really nice mutable data structure in Python that we can append things to. So right now this is an empty list. Think of it as a shopping list of that you've got a piece of paper, you've got your pen ready, but you actually haven't written anything on there. You have a conversation with your partner and they haven't decided what to put on the shopping list yet. So we've just made an empty shopping list. But we're going to add our numbers to it once we know what they are. And then I'm going to have my while loop. And let's say, as long as the length of my list is less than or equal to, let's say 20. So I don't really want it to be some crazy long number. I just, I want to limit the amount of numbers I print out. So that's my condition. As long as the length of that list is less than or equal to 20, then I'm going to keep on doing my loop. So as soon as I'm in my loop, I probably want to print out whatever I have for A. And then I'm going to use this little trick, end equals, to put everything in a straight line. And I'm also going to print out B. So I'm going to use this trick to put everything in a straight line. And now we need to do something. Well, let's just run this first. Will it allow me to? Oh, it doesn't like this line. Of course it doesn't. So let's just wrap this in triple quoted strings. Like that. Okay, stop. So I've just got 0, 1, and it's going on forever. You can see I've got the danger of an infinite loop. Why? Because I've got 0 and 1, and the length of that, the list isn't being updated at all, and it's always going to be less than 20. So it's just going to continuously run. But I am printing out A and B. So what I need to do is append my numbers using a built-in list method called append. I'm going to append A, and then I'm going to append B, and append will add to the end. So now I'm going to make sure that I am adding numbers into my list, and of course it does stop now. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, right? So it is stopping. But what I need to do is update the values of A and B. So what I need to do here, I'm getting an extra pair, which we'll sort out later. Fibonacci list. And then what I'm going to say is my new value of A, which you can see, I'll put as capital A. So you can see what my new value of A is going to be my previous value of A plus B, 0 plus 1. So 0 plus 1 is 1, right? And now I've updated what A is. A is 1. I can say my new value of B, which I put as capital B up in that comment, is also going to be A plus B. So A has been updated to 1. B was 1. 1 plus 1 is 2. And that gives me the next adjacent pair of numbers that I need. And if you keep on doing that, what we'll have, if I just clear the console, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 30, 55, 89, etc. So that way I can be really careful about my how many times this loop goes round. Anyway, I could tidy that one up a little bit, but I think you get the idea of how while loop's working. I don't want to put too much extra content in there. Good. Okay. See you in the next video.